Let's try a limiting reactant problem. In a limiting reactant problem, you're going to be given two numbers, an amount for each reactant, and you're going to have to figure out which one do you run out of and which reactant will you have excess, left over. So in order to do this, I'm going to use a BCA table because I find it to be the quickest method. You can continue to use your factor label. I just find them slow, and so I'm going to opt to do it my way. You can continue to do it your way as long as you can do it pretty quickly. Okay, so let's take a look at this problem. It says methyl alcohol is created by reacting carbon monoxide with hydrogen gas. So I'm going to write this equation out. I'm going to write CO plus 2H2 goes to CH3OH. And I'm going to write my B for before, my C for the change, and A for after. And I'm going to make a dividing line so that we know anything under that line is what I have at the very end when I want to answer this question. Now, let's take a look at the problem. I'm told that I have 12 grams of H2. So I can't just stick that in my BCA table. BCA tables only handle moles. So I first have to convert this 12 grams of H2 into a mole. So underneath here, I'm going to say 12 grams of H2. And you could factor label this. I just know that if I have a mass, I can divide by the molar mass to get my moles. So I know that the molar mass of hydrogen is 1. And so if I have H2, the molar mass is 2 grams per mole. And if I divide 12 by 2, I get 6 moles of H2. So I'm going to put that up here as my before answer there. I have 6 moles of H2. Let's do the same thing over here. 74.5 grams of CO. So I've got 74.5 grams. And I'm going to divide by the molar mass of carbon monoxide. Carbon's 12, oxygen 16, so that is a molar mass of 28 grams per mole. And I've already broken out my calculator and done this math, so I know that this is 2.66 moles. Okay, so let's pause for a second because a few of you are probably freaking out that carbon's atomic mass is actually 12.011 and oxygen's 15.999. I know that at the end of this problem here, I'm going to need about 3 significant figures. So I roughly have 3 significant figures here. If I were doing this on WebAssign, I would be a lot more careful about taking a whole bunch of significant figures with me, but I don't need them right now. The other thing is that if this were an AP test, AP expects you to round like crazy like this. And as long as you show your work, you're going to be fine. They don't expect you to use like 4, 5, 6 decimal places. They just expect you to be able to round to a reasonable number of significant figures. So let's move this thing up. My number 2.66 moles right here. And now we begin to get into the process. So it says which of these reactants is in excess and which one is my limiter. So the quick way you figure that out is you take your moles. I have 6 moles of H2 and I have 2.66 moles of the carbon monoxide. And I'm going to divide them by their coefficients. So the coefficient of H2 is 2, and that's going to give me 3. And the coefficient of the carbon monoxide is not there, which means it's a 1. So when I divide that by 1, that's going to give me 2.66. Now, this number is totally useless. Never use it again. However, it's an indicator of which one is your limiter. The smaller number is always your limiting reactant. So the 2.66 is my limiter. And the larger number is my excess. So now I can answer the questions above. I know that my limiting reagent is the carbon monoxide. And I know that the excess must be my hydrogen because it had the larger number. So my hydrogen's the excess and my carbon monoxide is the limiter. So from now on, I'm only going to work with the limiter. The limiter, actually, if we do it right here, I'm going to use it all up and be left with 0 moles. How do I know that I use it all up? Because it's the limiter. It's by definition, it is the thing that you run out of. So I know that number for sure. Now, of the 6 moles, how many of those 6 moles am I going to use? At this point, I don't know. So that 6 moles is a fake number. I might use 5.99 or I might use close to 0, and I won't know until I do the math. So let's get back to our BCA table. Everything is based off of the change. So I'm going to take this change here. Let's put a box around this. I'm going to take my change and I'm going to set up a ratio. So the ratio that I have, I know that 1 CO is related to 2 H2s. And I get that from my balanced chemical equation. Okay. I also know that I have a change of negative 2.66 moles of CO, and I'm looking for how many moles of H2 I'm going to produce, or in this case, how many moles of H2 I'm going to use. So if I cross multiply, I get X equals 5.32 moles. Again, I did the math already, so I didn't have to break out my calculator. So this thing is negative 5.32 moles. And the question is, like, why? What's going on there? Why is it negative? It's because I'm using up my reactants. So in the end, I'll have less of them. So if I take the 6 moles and subtract 5.32, I'm going to get a leftover of 6.79 moles. And at this point, I should be driving you crazy. I went from 1 significant figure, and now all of a sudden I'm giving an answer of 3 significant figures. I actually, I know in my head that this 6 was a perfect 6. It's basically 6.00. And I know that in the end, I'm going to need 3 significant figures. So now I'm starting to tighten up the way that I handle it. Okay, so it says, what mass in grams of the excess reagent is left over? Well, I know that I have left over 0.679 moles of H2. And I know if I take that 0.679 moles and I multiply it by the molar mass of H2, which is 2, then I will get the leftovers. It happens to be 1.36 grams of H2 is left over. So let's just double check that. This is like roughly 0.7. And if I multiply 0.7 by 2, I'll get 1.4. And I'm in the right ballpark. So I know that my calculation was good. So what mass in grams is left over? That's 1.36 grams of hydrogen left over. Okay, now we get to the methyl alcohol part. We need to go back and we need to do another ratio. So there's no number here out in front. So I know that's a 1. And I know that my ratio is actually a 1-to-1 ratio. So for every 1 carbon monoxide, I get 1 methanol. And I know my change was 2.66 or negative 2.66. So I can put this as an X. And when you cross multiply, you find out that X is 2.66 moles of CH3OH. Now, I'm going to enter that as a positive 2.66, which again should not be like, what are you doing, Sturman? Why? How does this suddenly a positive? Products get produced, so they're going to increase as the reaction goes, so it gets a positive answer for the number of moles. Now, how many moles of methanol did we start out with? We started out with none. We have 0 moles of methanol because in the beginning, methanol is a product. and it hasn't been produced yet. In the beginning, methanol starts with nothing, and then we build it up. So we wind up having 2.66 moles of methanol. It says how many grams of methanol or methyl alcohol will I produce. So I'm going to take this 2.66 moles and I'm going to multiply it. Let's take that there. Multiply it by the molar mass of the methanol. So a carbon is 12, 3 hydrogens, that's 3 ones, so that I'm up to 15. Oxygen is 16, so that's 31, and another hydrogen is 1, is 32. So 2.66 times 32 grams per mole is going to give me 85.1 grams. So in the end, I can say that I wind up with 85.1 grams of methanol. Let's go back, check sig figs. I had 3 sig figs here. I have 3 sig figs there. So I should be keeping 3 significant figures in my answer. I have 3 significant figures in this answer, and I have 3 significant figures here. So I'm good. Everything checks out.